Hello everyone, Slavomir here again, but today I'm not gonna drive a simulator because it's the very first time I'm gonna analyze real telemetry from a real car. So I hope you enjoy this video and I hope you find something useful, but I just want to warn you that it's gonna be a long video because I want to analyze in a detailed manner two laps of the same driver, but I will tell you more uh, in a second. So grab something to eat and to drink and we can start. So we run our software, and as you can see we have two files here. So one lap, slower one, was done on July the 1st, 2014, and the quicker one was done on July 19th. It was done by the same driver, and as you can see, both stints were approximately the same length. Here we have 10 laps, here 8 laps. You can see number of laps, and the best lap was done on the last hot lap of each stint, because the last lap was the out in lap, so the time was much slower. So the difference approximately 4/10 of a second, and we want to see where the driver gained that time, and we'll try to find places where more time could be gained in the future. So as you can see, the car is radical as SR3, so, and it has a lot of downforce. So it's maybe not the quickest car in the world, but it has a lot of downforce in corners. Okay, so let's open two tests at the same time. We press the control button and we click, and we open tests. Usually it's better to put the same GPS lap insert to just make sure, because sometimes when you open several tests, the graphs, the difference, the difference between the charts is unrealistically huge. So it's just better to put the GPS lap insert, and we do it like this. We click here, we select the only possibility here, we confirm, and we click continue, and we can have our lap times. In this case I think everything was fine, but just to make sure, because usually it's not the case. Okay, so shift F1 and the track map pops up, and that's how the track looks like. So let's begin. What we are going to analyze. We are going to analyze the speed, throttle position, brake pressure, and the last thing here is actually the most important one, because it shows the gap. So one more thing, the green one is the best lap, 37.7. The red one is 38.1. So every time this line is below, the red lap is faster. Every time the red line is above the green one here, which is the reference lap, the red lap is slower. So let's begin. Okay, let's zoom in the first section, which is the start-finish line, and the first thing you can notice is this speed difference. On the red lap, which on the slower lap, right? Look, you can see that the speed, actually the maximum speed was 216, whereas on the green one, the fastest speed was 212. So we have approximately 4 kilometers per hour difference. It could be because of the slower exit from the last corner, but I remember because the quickest the green lap was done just a couple of days ago. The weather was windy, so and there was a lot of wind on the main straight, so that's why this speed difference is so huge. Okay, so you can see that at this point, maybe here, at this point, so when on the red lap the brakes are applied, the difference is already almost 1/10 of a second on the red lap, which is the slower one. But what happens? Look, what's the difference in time and in distance between the application of the brakes on the red and on the green. It's huge. We can approximately see it here. We have the distance, approximately 268 meters from the start-finish line, where the brakes were applied on the red lap. And look, when the brakes on the green lap were applied, 294. So the difference is more than 30 meters. Here we have a very useful feature, delta. When we click here, and now we move it, you can see that it counts a couple of things, and you can see the value here is the actual distance. So yeah, approximately 30 meters. So it's a lot. Actually, that was the goal before. At the beginning of the day, I talked to the driver and I told him to brake later in this corner, because as you can see, this corner is very important because there's another straight. This corner is flat out, so it is considered a straight. So the speed in this corner is very, very important because you can gain a lot of time. Okay, so the first thing, or the first difference you can see, is difference in brake application in the corner. I mean, at this point, there's no point actually to analyze for how long the driver uses the brakes, but you can see that the maximum pressure the brakes produce is the same, 28. So he's very consistent on braking in this particular corner. Those blips here are is downshifting. Okay, so you can let's see now the throttle application. You can see that on the slower lap, the driver, let's switch off the delta function, the driver starts to apply the throttle earlier, approximately 77 to 92, so 20 meters more or less. But because of much more speed carried into the corner, even those 20 meters is not a difference in this case. But even though he applied the throttle much earlier, look that he was much earlier on the full throttle on the green lap, which together with more speed he carried into the corner and through the apex is gaining time, which you can see here. So at this point, so when he applied the full throttle, he already gained, remember, more than 3/10 of a second, because before the corner he was slower, right? Do you remember? Here is minus 80, 84, 80, 86, 87 thousand of a second. So at this point he's more than 3/10 of a second faster. Okay, and look at the speed. The difference in speed is big, because at this point we have 156 to 145, so more than 10 kilometers per hour, and still there's a lot of speed here to find. Unfortunately, here we have a very different spike. It's because when you exit this corner and you start applying the throttle around here, I mean, usually you should start applying the throttle around the middle of the corner, but when you start applying the throttle and you are very and you don't see the exit of the corner because you are sitting very low, sometimes well, you have to take a risk, because it's like you don't see the left side of the corner. So I in my opinion, he just he thought he could run wide, and remember, it's a quick corner, so that's why this thing occurred. And you can see what happens, that here there's a little drop, but nevertheless you can see that he's gaining all the time because of more speed he gained, he carried through turn 1. And we go here and up to, and before the braking zone and into the second corner, you can see that the difference is already more than 4/10 of a second, plus, remember, almost 1/10 of a second before the braking into turn 1, so more than half a second only in one corner. Okay, and let's zoom to this section here. Maybe, hold on, I want more here. Okay, so we start applying the brakes. Let's check the speed difference. 202 to 195, so 7 kilometers per hour difference is a lot. But what happens next? You can see that on the quicker lap, the driver starts braking earlier. Well, maybe because he knew he was faster. So if you carry more speed, then you have to brake slightly earlier. But to be honest, this particular corner is very tricky. If you overdo, then you can spin the car and go into the gravel. So he's very cautious here. And what happens? Look that on the quicker lap, the driver applies more pressure, which is, I mean, more pressure, brake pressure, which means he brakes more. And what happens? Only in the braking zone, look what happens with the chart here. Only here he lost approximately almost 3/10 of a second, because he braked earlier and he braked more. Actually, he could have braked at the same point, but more, with more pressure, or brake there, but with less pressure. Then this chart would have looked slightly different. Okay, and you can see that even though the driver applied the throttle earlier on the green lap, he was faster. He was full throttle faster on the red lap. So what happens? The chart here goes again down. So he loses time, even though you can see that he's quicker here, right? But look, this is very interesting, those two triangles. Look at that, where at what point he is in the slowest point in this corner. On the green lap, he enters the corner earlier, or he carried less speed earlier than on the red lap. So he was way too cautious on his quickest lap. Okay, so let's move forward. So he loses the time all the time, and we are approaching turn number 3. And what happens here? Same situation. He applies more pressure. He brakes almost at the same time. I mean the difference 60 to 64, 5 meters. So it's not a lot. But you can see that because of more brake pressure, the speed he carries into the corner is way lower. You can see 110 to 121. And then he was again quicker flat out on his slower lap. So what happens? Even though he gained a little bit here, because he started applying throttle on his on the green lap faster. He was faster flat out on the red lap, so you can see that the chart goes down again. So he loses the time, the time all way along. Okay, and we are approaching this right-hander. So only in those two corners he lost about 0.4 of a second. Okay, so we are approaching next turn number 4, which is actually, you can see, is a section of 3 corners, right, left, right. So let's zoom in here, and we have a very interesting mistake here. I will tell you very soon. Okay, so we are approaching the corner, and what happens? He brakes later on the green lap, which is good. Again, he carries more pressure on his on the green lap, but you can see that at this point the speed trace is almost the same. The difference in speed is less than 2 kilometers per hour. But on both laps, there is a thing which he should avoid at all costs, and this is it. This place here. Look, he applies the brakes, then he releases the brakes, and then he realized he can brake more, so he again applied slightly more pressure, and you can see it here and here, and that's the mistake. look here. This is ideal, I would say, ideal braking curve when you release the brakes. So he should improve. He should work more on braking on braking zone here. Okay, so what happens? You can see he gained a lot of time here on in this right hander. I mean, he lost even more time in this right hander. What happened? First of all, braking throttle application. Look how much earlier he is on the full throttle. Let's use our delta function. 90 meters earlier on the full throttle. So there's a lot in this corner, and he's longer on the full throttle on his slower lap. So again, he loses time. So at this point, which is this left-hander, he is almost 0.3 of a second quicker on his slower lap. Okay, but what happens next? Very interesting. It's very interesting. Again, good throttle work. Of course, without this flat area here, it would be perfect. But is, I would say, good. And he's again much faster on the throttle. Let's see. More or less 22, 23 meters. And what happens? Look at the speed he carries exiting the corner. Even though he lost here in this section, it's slow in, fast out. He carries more speed on his quicker lap, plus he is early on the throttle, and you can see that he starts gaining time. So we are on the straight here. This corner is flat out, and on the next braking zone, which is here, he is almost zero, right? But he gained a lot of time in this section. I mean, actually, from here, because he could have gained more time braking into the turn number 4, but he gained a lot of time exiting turn number 6. Okay, and we are approaching this left-hander. What happens here? Let's zoom in. What happens here? You can easily spot much more braking force, 21 to 15, so it is a lot, but you can see that he's longer on the throttle, and because of that he carries much more speed into the corner, so he is gaining time. Here we have a mistake on his quicker lap, but again, because of much more speed, you can see here the difference is 10 kilometers per hour because of earlier throttle application, but then he realized, in his opinion, he was too quick on the throttle, so he released a little bit and again used full throttle. And by the way, this is just perfect throttle application. That's what he should focus on most. Good throttle application exiting the corners. So even though on his slower lap he was much faster on the throttle, this earlier throttle application on the green lap, plus which gave him more speed, was quicker than he was quicker on the green lap than on the red lap, on the red one. So you can see that he's gaining the time. And now we are approaching very interesting corner. It looks like it's one corner, but actually it's a chicane. It's left, right chicane. But the line is you cut the curbs on the left and on the right, and you go straight. The goal is to go straight as possible, and then turn only once here in this right hander. And what happens here? There's also very strange thing, because he released a little bit the throttle, and then you can see this is the flat area, and then he released the throttle fully, and he is slightly longer on the throttle, so he carries much more speed into the corner, and he's gaining time. But again, more brake pressure means less speed. And what happens? You can see that those two lines here are they are not the same, or they are not similar, because you can see here there's a triangle here. He starts applying the throttle on the green lap faster, but then there's a very long flat area, whereas on the red one the throttle application is much better, and they meet approximately at the same place. So what happens? Exiting the chicane, he loses time again, 0.3 of a second, and braking into the last corner, the gap is almost 0. So again, exiting the chicane was the problem. Okay, and we are approaching the last corner, and as you can see, it's very, very interesting. And what happens here? The speed is almost the same, but on his first lap, he is longer on the full throttle. The brake pressure is almost the same, and you can see that on the green lap he uses less pressure, which means he braked less and thus carried more speed into the corner. And look at the throttle application. Let's say he was almost he started applying the throttle at the same place, but look what happens here. His full throttle here on the quickest lap, whereas on the slower lap there's a huge valley here. So it was a very, very big mistake, especially because this corner brings us to the fastest and longest straight on the track, and you can see that he gained a lot of time. So he was 0.1 of a second faster here, and only on, I'm wondering what is the distance here. Only on 187 meters he gained almost 0.3 of a second only. So that was good analysis of one driver on his two quickest laps. And as you can see, there's still a lot of room. I think about 3 seconds or even more maybe 0.3 of a second is to be found. So, and you can see that the lap isn't is good, but isn't how to say, it's not very consistent. Sometimes on his slower lap he was quicker, sometimes he was faster, so that's what we should avoid. But what conclusions can we draw from this? I just forgot to mention one thing. Hold on. No, it looks like sometimes there's a problem. I can't use the GPS data from both from this. So I wanted to show you the line, but unfortunately I can't do that. Okay, so what conclusions can we draw? Because I can't tell the driver all things I told you in this video. First of all, the first priority is braking into turn 2 and into turn 4. I would say that's the first priority, where he can gain a lot of time. He can brake later here in turn number 4, right? And maybe a little bit later or with less pressure into turn 2. The second priority is turn number 1, because he achieved his goal, which was to brake later, but still he can move this braking point, 2, 3, 4, 5 meters ahead, or he can apply less pressure, which gives him more speed into the corner, because there's still a lot of time to gain to find it there. Plus the car has a lot of downforce, so the car is stick to the ground a lot. And the third priority, I would say, is the chicane, because the goal is, of course, to, as I said, throttle application. Apply the full throttle only when you're sure you can apply it flat out, right? Here we have a almost perfect example, despite this one thing, of good throttle application. Here there's a very good throttle application here. So you can see one mistake here. This is also a little mistake, but it didn't cost that much. And of course braking, as I said. So for the next time we meet with the driver, I'm going to tell him later braking into turn 2 and into turn 4. And in my opinion, two goals for a session or for a day is enough. You can see that before on the session we did, or the driver did, the quickest lap, he was only one goal. He had only one goal, to brake later into turn 1, and the goal was achieved, and a lot of time was gained, almost half a second. So that's a very good point. But unfortunately, you can see that there's time when on his slower lap he was faster, and it was this section 4, 5, 6. But because of braking too early into turn number 4. So for next time we meet on the track, those two things will be priority 1 things, and I will try to upload you another video with another telemetry, and I will try to show you all 3 laps, and we'll see those differences. So it looks like that's all. Unfortunately, I couldn't show you the line of the GPS line from those 2 stints. I have to figure it out why it doesn't work here. It works on my laptop, because now on my PC, and it doesn't work here. It's not the first time I have this issue. But what I can tell you is braking into turn 1 on his faster lap, he didn't use all the lengths, all the width of the track. He wasn't on his right side. I mean, on the right side of the track, about I think 2 meters. He could have been more to the right. So, but unfortunately, I can't show you that. You have to believe me. Okay, so thanks for your time. I hope you enjoyed the video. I hope I explained the telemetry well, and you could find something useful from this video. And subscribe if you haven't done it yet. Share, like, leave your comments, and I hope to see you very soon. Take care and bye.